Hello students, good morning. Today we learn about 3D geometry, a topic of class 12th, JEE Mains and Advanced as well. So in this topic we learn about two major things. First, line in 3D and second, plane in 3D. Plane in 3D, this topic is dated from boards and JEE Mains. This topic only in JEE Advanced. So first of all, we learn about lines in a plane. Okay, so in lines we have to learn about equation of line, how to find equation of line in 3D. You have read about equation of line in 3D already in class 11th, coordinate geometry. Now we study about line in 3D. So equation of line in 3D. Okay, so first form of equation of line is when point on the line and vector parallel to a line is given. When point on the line and vector parallel to a line is given, then how to find a equation of line? So in this form we have to find equation in this formula: x minus x1 by a, y minus y1 by b, z minus z1 by c. Here x1, y1, z1 is given point and ai cap, bj cap, ck cap of parallel vector to the line. In diagram you can see, let's say this is a line, okay, and this line passes through this point which is given x1, y1 and z1 and a parallel vector, let's say this, which is ai cap, bj cap, ck cap. Okay, so whenever a point on the line and vector parallel to the line is given, we can find equation of line from this formula. Okay, so now we see how to derive this equation of line, this formula, how to derive. So let's try to understand. First of all, we have to know about what's the equation of line or any curve. So equation of line or any curve means relation between coordinates of all points. Relation between coordinates of all points lying on any curve. So let's say we have a line and these all points are lying on this line. So we have to find equation of line. That means we have to establish a relation between x coordinate, y coordinate and z coordinate of all these points. Okay, these all points are lying on this line. So there must be a common relation between x, y and z coordinate which satisfy all these points. Okay, so for finding equation of line, let's say we assume a variable point. We assume a variable point on this line. You can say this is a point, or as this is a variable point, so this point can move along this line, this side or this side. Okay, so this point you can assume this point, or since point is variable, you can take this point also, this point also, this point also, this point also. Okay, so let's say very carefully, if point is variable, so point can move along this line. Okay, but if point is here, we create a vector. So we have this vector. If point is here, we create this vector. 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 If moving point or variable point, if lying on this line, okay, we create a vector from this fixed point and ends with this variable point, this vector, this vector, this vector, this vector, or this vector. And if you see very closely, this vector is parallel to this vector. This vector is also parallel to this vector. This vector is also parallel to this vector. This is parallel, this is parallel. If point move in any manner, in all manner, if we create vector, this vector always parallel to this vector. Okay? So, we can take any point, but let's say we can take this point. Okay? Let's say this point is vector r. We assume position vector of this point is vector r, which is variable. Okay? And this point is already given. So, you can say position vector of this point is vector A. x1 I cap, y1 j cap, z1 k cap, position vector of this point. Okay? This is given. This is assumed by me, and this is parallel vector. So, here we can clearly say vector r minus vector A. You can assume this point is point A. You can assume this point as point B. So, clearly we can say AB vector is parallel to this vector. You can assume this vector as anything, like let's say vector B, not B, because B be common, so you can take any other name, any name. Let's say you can take vector U. Okay, this is vector U. You can take any name here. So this AB vector and this U vector is parallel. Okay, so if AB is parallel to U vector, so we can write AB vector is equal to lambda times vector U. Okay, now let's see AB vector, AB vector, position of B minus position of A, that means R minus A. We can write vector R minus vector A is equal to lambda times vector U. So here we can write vector R is equal to vector A plus lambda times vector U. Okay, this is the equation of line in vector form. Okay, we can convert this equation in this form. This is called Cartesian form. Let's see how can we convert. Okay, in NCERT books, always given vector R equal to vector A plus lambda times vector B. You can take any name here. Okay, so no problem. Now, how to convert this vector equation in this Cartesian form? Let's say this is vector A, coordinate x1, y1, z1. This is R, position vector R. For converting this equation in Cartesian form, you should take vector R is equal to x1 I cap, y1 j cap, and z1 k cap. Okay, vector A is equal to x1 I cap, y1 j cap, z1 k cap. Put this value in this equation. Vector R. Vector R means what? X I cap, y j cap, and z k cap. Vector R is equal to vector A. Vector A means what? X1 I cap, y1 j cap, z1 k cap. X1 I cap, y1 j cap, z1 k cap plus lambda times vector U. This is vector U. Put here A I cap plus B j cap plus C k cap. Okay. Now rearrange this equation. So we can write here x1 I cap lambda times a I cap. Okay, so I cap take common. You can write x1 plus lambda times a into I cap, y1 j cap, lambda times b j cap. So take j cap common. You can write y1 plus lambda times b j cap, z1 k cap, lambda c k cap. So you take common k cap common. You can write z1 plus lambda times c k cap. Okay, this is equal to x I cap, y j cap, and z k cap. Now this vector is equal to this vector. If two vectors are equal, that means coefficient of I cap must be equal, coefficient of j cap must be equal, coefficient of k cap must be equal. So we can write x is equal to this, y is equal to this, and z is equal to this. So finally we have x is equal to x1 plus lambda times a, y is equal to y1 plus lambda times b, and z is equal to z1 plus lambda times c. If we calculate lambda from all three equations, we have lambda is equal to x minus x1 divided by a. Here lambda is equal to y minus y1 divided by b. Here lambda is equal to z minus z1 divided by c. Lambda equal to x minus x1 by a, y minus y1 by b, z minus z1 by c. All three are lambda, so that must be equal. So finally we can write x minus x1 by a, y minus y1 by b, z minus z1 by c is equal to lambda. So in Cartesian form, this is the Cartesian form. Generally, we don't write lambda, but it's very important. Its role is very important. So when its role is important, we write. Okay. Currently, no need. So this is the equation of line in vector form, and this is in Cartesian form. Now, in this topic, we have second form. That form is whenever 2 point is given on the line. So let's see how to find equation of line when 2 point is given on the line. So let's say we have a line and 2 points on this line are given. Let's say first point is x1, y1 and z1, and second point is x2, y2 and z2. So how to find equation of line? Okay, so whenever 2 points is given, no need to worry, we have to apply same method as previous. So in last method, we have x minus x1 by a, y minus y1 by b, z minus z1 by c. This is the equation of line. Whenever 1 point is given, x1, y1, z1 is 1 point, and ai cap, bj cap, ck cap is parallel vector. Okay, so here we have 2 points, but no direction, no parallel vector. But nothing to worry, we itself create a parallel vector by joining these 2 points. Let's say this point is A and this point is B. So AB vector, if we create AB vector, we have x2 minus x1 I cap, y2 minus y1 j cap, z2 minus z1 k cap. So this AB vector represent direction of line. So New formula for equation of line is x minus x1, y minus y1, z minus z1. In previous, parallel vector is what? Ai cap, bj cap, ck cap. Here, instead of writing ai cap, bj cap, ck cap, we write x2 minus x1 I cap, y2 minus y1 j cap, z2 minus z1 k cap. This is equivalent to A, equivalent to V, equivalent to C. So, new equation is, rather than writing A, B or C, we write x2 minus x1, here y2 minus y1, and here z2 minus z1. So, this is the equation of line whenever 2 points on the line is given. Okay. So, these are the main 2 different formula for equation of line. Now, in this topic, we have to learn about angle between 2 lines. Okay. But angle between 2 lines, before this, we have to learn about direction cosines and direction ratio. Some teachers teach these topics in starting. I teach after this point. It's more useful. So, before studying about angle between 2 lines, we study about direction ratio and direction cosine. Direction ratio and direction cosines. Okay. In short form, we write DRs and DCs. First, we learn about direction cosine. Okay. And direction ratio, both are interlinked, and you can say both the term represent same thing. Its name is direction ratio or direction cosine. So both the term represent direction of a line. So let's see by example. We have a line. Okay. So if we take any vector, parallel to this line, any vector parallel to this line, any vector. Let's say this vector is ai cap plus bj cap plus ck cap. Okay. So, coefficient of I cap, j cap, k cap. Coefficient of I cap A, coefficient of j cap B, and k cap C. So, these A, B, C are called direction ratio. A line, okay, parallel vector to this line. Any vector which is parallel to this line, in that vector, coefficient of I cap, j cap, and k cap, that means A, B, or C, is direction ratio. Okay. And direction cosine is what? Same thing. A line of parallel vector as well as unit vector. You can say we have a line. Okay. If we take a parallel line, if we take a parallel vector to this line, okay, and coefficient of I cap, j cap, k cap is direction ratios. Okay. If we take a parallel vector but unit vector, parallel vector but unit vector, magnitude must be 1. Okay. So generally we write this vector is L I cap, M j cap, and k cap, parallel vector as well as unit vector. So coefficient of I cap, j cap, k cap is direction cosine. Here L, M, and N are direction cosine. Direction ratio, direction cosines. Both are same thing because both vector is parallel to this line. Okay. line parallel vector. If magnitude is 1, then coefficient of ijk is called direction cosines. If magnitude not equal to 1, then it is called direction ratio. Okay. One other explanation of direction ratio and cosine. Let's see what is this. Mainly direction cosine. So its different approach is direction cosine. We have a line in 3D. This is x axis, this is y axis, and this is z axis. Okay, and we have a line in 3D. Let's say we have a line in 3D passing through origin. You can take any line, but if we pass through origin, it's easier to make you understand. That's why I take a line from origin. So this is a line. Direction cosine of a line we try to understand. So another approach is we have a line, okay, in 3D, and this line forms angle with x-axis, angle with y-axis, angle with z-axis, some angle. Let's say this line form alpha angle with x-axis, beta angle with y-axis, and extend this z-axis, and gamma angle with z-axis. A line in 3D, so this line must be form some angle with x-axis, with y, with z. Okay, so alpha angle with x-axis, beta with y-axis, and gamma with z-axis. Okay, so cosine of these angles, cosine means cos, cosine of these angles means cos alpha, cos beta, and cos gamma. Cosine of these angles are called direction cosine. Generally, we can write this as L, this as M, this as N. Same, L, M, N. Both are same thing. So a line are forming some angle with positive x-axis, some other angle with positive y-axis, and some angle with z-axis. Cosine of those angles are called direction cosine. Okay, so these are direction cosines: cos alpha, cos beta, cos gamma, or you can say L, M, N. And I already told you about direction cosine in this manner. This approach and this approach both are same thing, but both approach are different usages. Okay, that's why we describe this in two ways. Here, direction cosine and direction ratio, in simple word, remember, direction cosine means a unit vector parallel to a line. Unit vector parallel to a line, coefficient of I cap, j cap, k cap of that unit vector is direction cosine. Line parallel vector, unit vector, coefficient of I cap, j cap, k cap is direction cosine. Line of parallel vector, its magnitude can be anything, one also anything. Line parallel vector, coefficient of I cap, j cap, k cap is direction ratio. If we convert this magnitude into 1 by converting in unit vector, as you know, if we divide any vector by their magnitude, we get a unit vector. So if we divide this vector by their magnitude itself, so A I cap, B j cap, C k cap divide by A square, B square, C square under root. Now this vector convert into unit vector. We can write this as A I cap, divide by a square b square c square plus bj cap divide by a square b square c square plus ck cap divide by a square b square c square under root. So now this is a general vector and this is a unit vector in same direction. So now coefficient of here I cap, here j cap and here k cap, these are direction cosines L, M, N, because these are unit vectors. Line parallel vector and unit vector in same direction. Unit vector in same direction with one magnitude. So you can say L, M or N. This is direction cosine, direction ratio. It's clear? Okay. Now in this chapter we have next topic is how to find angle between two lines. Okay. So before finding angles between two lines, first of all we have to understand in 3D geometry what's the terminology, what's the component describe, determine the direction of a line. Because angle means what? Angles between two lines. That means inclination or orientation between two lines. Okay. So it's first line and it's second line. In line we take a vector for its direction. In line we take parallel vector for its direction. Okay. So in line direction is all depend on these parallel vectors. Okay. So angle between lines is equal to angle between vectors. Line parallel vector, line parallel vector. If we shift these vectors to this point of intersection, we can shift this vector. You have read about this. We can shift any vector from anywhere to anywhere, but keep one thing in mind, in same direction and with same magnitude. So we can shift this vector to this point. Okay, in same direction with same magnitude. We can shift this vector to this point in same direction with same magnitude. So here now it's very clear, angle between these vectors is equal to angle between these two lines. Okay, so let's say it's line 1, it's line 2. So you can say this is vector b1 parallel vector, this is vector b2 parallel vector. Okay, so we have to find angle between these two lines. In other words, we have to find angle between these two vectors. And you know already, whenever we have to find angle between two vectors, generally we use dot product of vectors. b1 dot b2 is equal to b1 modulus b2 modulus or magnitude into cos theta, where theta is angle between these two vectors. Okay, so we have to find theta. So you can write here cos theta is equal to b1 dot b2 divided by b1 mod b2 mod, or you can say theta is equal to cos inverse b1 dot b2 divided by b1 mod b2 mod. Okay, so in this way we can find angle between these two lines. Okay, in this chapter we have a last approach, so many topics but a single approach. By that single approach we can solve any question of next all topics. Next all topics are, first of all, how to find point of intersection of two lines. Point of intersection of two lines, or whenever you have to find foot of perpendicular. Okay, or how to find image of a point respect to a line. And next topic is how to find perpendicular distance, or you can say shortest distance from a point to a line. And last one is distance between two lines. For solving all these concepts, we have to use a single approach. Let's see what the single approach. How to find point of intersection or the perpendicular or image of a point or perpendicular distance.